You are going to need out a piece of paper to do your notes, for sure. You are going to need out your purple sheet, okay, for sure, because we're going to add at least 3 formulas to your toolbox off the purple sheet, okay? And then depending on how far you get on the extras, the stuff after the notes, then you might add 6, okay? So this sections is going to be 5.3, which we're gonna nail. We're gonna get done with section 5.3 in the next half an hour. Okay, all right. So that one's gonna be done. Okay. 5.4 is going to be then the rest of class today and tomorrow's class. Okay. Then Friday and next week is going to be all about 5.5 and the start of 5.6. Okay. 5.5. So today is sum and differences of identities. Tomorrow is double and half angle identities. Friday is law of sines, then followed by law of cosine. Okay? All 4 of those will encompass your next summative assessment, which will be sometime end of February-ish. Okay? Sometime that last or week before in February. Okay? We haven't quite figured out the date yet. So. But you will have a take-home formative this week, Friday. And so we didn't have time to take it on Friday. We needed the day because we got to pick up the pace a little bit to get everything that we need to have done. Okay? So just so you know that. If you could do these 2 warm-ups for me right now, that would be awesome sauce. So this really means x plus 5 times x plus 5, which really means x squared plus 10x plus 25. Okay? The classic math blunder here is people see that and notice how this is not just x squared plus 25. They see that squared and they just want to square each of those terms and call it a day. Okay? That is one of the Hall of Fame math algebraic blunders of the world, which you'll see on the next slide. You'll see the other 2. Okay? So that is what that one should be. Don't be that person that makes that blunder. Okay? This one is the square root of 25, which is just 5. Okay? Not the square root of 9 plus the square root of 16, which would be 3 plus 4, which would be 7. Okay? Another all-time classic math blunder. Okay? So here is our Hall of Fame of algebraic blunders. Okay? The first one we see a lot. We see a lot. Lots of people forget that means u plus v times u plus v. And they just want to square u and they just want to square v. The square root one, like example number or warm up number 2, that one not as much, okay? But we see it a lot in number 3 when we have f, when we take the function and we want to evaluate the function at something, and then you try and split it up. Okay? The reason that we're talking about those algebraic blunders is because of this. This is what we're going to deal with today. We're going to talk today about sine of u plus v. Now, you want this to be, or you would love it if it were, but it's not the sine of u plus the sine of v. But you want it to be because you want it to be that easy. Unfortunately, it's not. Okay? But we'll deal with it here momentarily. So, rid of all that. I'm not a big fan of the highlights. Okay? So if u and v are angles in radians and degrees, okay, cosine of u minus v would be something like this. So we would be saying here, what we want to find here is we want to find the cosine of 15 degrees. Okay? And 15 degrees is 60 degrees minus 45 degrees. Now, this is not the cosine of 60 degrees minus the cosine of 45 degrees. Okay? It is, however, on your identities, on your purple sheet, we'll go right to the identities because here they are. Come on down for me. Come on down for me. There we go. You get this one. Let me move this one up first right away. Okay. So here are these. Now we have combined them on your sheet to save space. So for instance, these two, the cosines, are number, I believe it's 18 on your sheet, but we have it written as the cosine of u plus or minus v is equal to the cosine of u times the cosine of v minus plus the sine of u times the sine of v. Okay? Those are opposite operations. Okay? So if you're adding in what you're trying to do with your trig function, you're going to subtract when you apply number 18. Okay? I am by no means saying that you have to memorize these. You will get a purple sheet or the pink sheet, the new pink sheets that we have with the unit circle right on them. You will get those for all of your summatives and going forward. And you can use your own purple one for your formative this week. Okay? But you get that. Okay? On sine, we combine those into number 19, and that would be the sine of u plus or minus v is equal to the sine of u cosine of v plus or minus cosine of u sine of v. That one, you're adding or subtracting stays the same. Okay? Tangent is number 20 on your sheet. The numerator matches what you're doing from the problem. The denominator is opposite what you're doing from the problem. Okay? Now, I could spend hours on end talking to you about how we got those, how we derived those, all that fun stuff. But instead, I'm going to fast forward and we're going to do. Okay? So we're just going to go in and we're just going to do. Okay? So I want to find the exact value of the cosine of 75 degrees. The downfall is that 75 degrees is not on our unit circle. I need to be exact because in this unit we're all about exact. We're not about decimals whatsoever until we get to law of sines, law of cosines. Then maybe we'll be about decimals. Okay? So I need to know what 75 degrees is from two unit circle angles. So give me two unit circle angles that when combined give me 75 degrees, either with addition or with subtraction. 15 is not on the unit circle. 30 and 45. Okay? So this could be the cosine of 30 degrees plus 45 degrees. Okay? All right? Now my cosine formula, number 18, is opposites, right? Okay? So actually, let me go back here and we'll color code it. Okay? So this would be then the cosine of 30 degrees times the cosine of 45 degrees minus the sine of 30 degrees times the sine of 45 degrees. Agree? Unit circle work now. What is the cosine at 30 degrees? Cosine at 30 degrees. The cosine. Square root of 3 over 2. The sine will stay at 30 degrees. The sine at 30 degrees. 1/2. The cosine at 45 degrees. Root 2 over 2. And the sine at 45 degrees. Also root 2 over 2. My left set of parentheses. Square root of 3 over 2 times the square root of 2 over 2. Go ahead, Dan. Okay, simplify square root of 3 times the square root of 2. Which is? Equal. Square root of 6 over 4. 1/2 times the square root of 2 over 2. Square root of 2 over 4. Can I simplify that expression? What do I need to add and subtract fractions? Common denominators. Do I have that? Yes, I have that. Okay? My numerator then becomes do we agree with the numerator becomes the square root of 4? Not getting a lot of support. Okay, what does my numerator become then? All of that over now. I'm going to counter this same problem. What if I said instead the cosine of 75 degrees was the cosine of 135 degrees minus 60 degrees? Is that still a true statement? 135 minus 60 is 75. Okay? Then this would become the cosine of 135 degrees times the cosine of 60 degrees. Instead of minus, now it would be plus, because my signs are opposite, the sine of 135 degrees and the sine of 60 degrees. Cosine of 135. Negative root 2 over 2. Cosine at 60. One half. Sine at 135. 2 over 2. Sine at 60. First fraction is negative root 2 over 4. Second fraction is square root of 6 over 4. So this one gets me negative square root of 2 plus the square root of 6 over 4. Are those the same? Yep, those are the same. Yep, those both work. So, is there one way to do all of these problems? No, there's a bunch of different ways to do these problems, as long as you're still finding the cosine of 75 degrees. 30 plus 45 is 75. 135 minus 1 or minus 60 is 75. In the last class, they did 225 minus 150. Still is 75. Okay? Could have done 315 minus 240. Okay? Could have done a lot of different ones, as long as your two angles that you're choosing are on the unit circle. Okay? Let's kick it up a notch. Okay? Now, we're at 5 pi over 12. We want to find the sine of 5 pi over 12. So I need two angles. So I'm in my brain, over here off to the side, I'm thinking, all right, 5 pi over 12 is, give me a combination of unit circle angles that gets me 5 pi over 12. Not that easy to do, right? Okay, let's take a step back. Give me a combination of numbers, not on the unit circle, just of numbers, that add up or subtract out to be 5/12. Don't even think too hard at it. Give me what's the first pair that jumps right off your head? For me, it's 2/12 plus 3/12, right? What do you got, Trick? Pi over 6, pi over 4. Are those both on unit circle? Yeah? Okay. Give me another pair.
3 pi over 4 minus pi over 3.
3 pi over 4 would be 9 pi over 12 minus, we need to get to 4 pi over 12. So that would be 3 pi over 4 minus pi over 3. Is that what you had said? Yep. As long as they're on the unit circle, it works. No, pi over 3. Correction. Over 4. That one work? Any of those works, right? Use one of those or make up your own. Find me the sign at 5 pi over 12. Exact. No decimals. That's going to be the sine of pi over 6. Cosine of pi over 4. Sine at pi over 6 is 1/2. Cosine at pi over 6 is square root of 3 over 2. Cosine at pi over 4 is the square root of 2 over 2. Sine also is that. So I get the sine of 5 pi over 12 is going to be the square root of 2 plus the square root of 6 all over 4. I would also accept, depending upon your angle preferences that you chose, I would accept the square root of 6 plus the square root of 2 all over 4. Yes? No? Maybe? Yeah? Yeah? Let's do a tangent. So again, we're thinking 11 pi over 12. I need a combination of two angles, and it gives me 11 pi over 12. Both of them have to be on the unit circle. So what adds or subtracts to be 11? Add and subtract to be 11. 6 and 5. 6 pi over 12 reduces to pi over 2. 5 pi over 12. Is 5 pi over 12 on the unit circle? Nope, we can't use that. Okay. Next pair. 15 and 4. That would be 5 pi over 4 minus pi over 3. Okay. Another one. Nine plus 2. Eight plus 3. Yeah. Why did I choose this one? Well, they could have also done the very first one too. Why don't I like the middle one? I know. So I would need to know the tangent of 3 pi over 4, right? What's the tangent of 3 pi over 4? -1. That one's okay. I got no problem with that one. And I would need the tangent of pi over 6. What's the tangent of pi over 6? So I got fractions, right? Okay. As opposed to, if we do this one, so this is going to be the tangent of 2 pi over 3 plus the tangent of pi over 4 all divided by 1 minus tangent of 2 pi over 3 times the tangent of pi over 4. What's the tangent at 2 pi over 3? Tangent at 2 pi over 3. You guys should have these. These shouldn't be that hard to figure out at this point in time. Yeah. Negative square root of 3. Tangent at pi over 4. Okay. Which one's easier to work with? 1 over the square root of 3 or negative square root of 3? Negative square root of 3 is easier to work with, right? Okay. Less denominators that you have to combine. Okay. So tangent at 2 pi over 3 is negative square root of 3 plus tangent at pi over 4 is 1 all over 1 minus tangent of 2 pi over 3 is negative square root of 3. Tangent at pi over 4 is 1. Let's make the top look good. How can I make the top look good? 1 minus square root of 3. How can I make the bottom look good? 1 plus the square root of 3. Because you have me, we're done with that one. If you had Schmelling, or you rational. By the conjugate over the conjugate. Yeah. All right. So that is an example of using each one of those. Okay? They're pretty much straightforward. Here's the formulas. Use them. Okay? We can also go in reverse. So if we have cosine of 42 degrees, cosine of 12 degrees, plus sine of 42 degrees, sine of 12 degrees, which one am I using? Sine of some are difference of sine, some are difference of cosine, some are difference of tangent. Cosine? And is it going to be a sum or a difference? So this would be cosine of 42 degrees minus 12 degrees. Agree with that? Oh, what's 42 minus 12? 30. So this would be the cosine of 30 degrees. What is the cosine at 30 degrees? With me? Sine of 7y times the cosine of 3y plus the cosine of 7y times the sine of 3y. Am I dealing with sums or differences of sine, cosine, or tangent? Sine, is it a sum or is it a difference? Sum. Seven y plus 3y. So that simplifies to be the sine of 10y. Tangent of 3b minus tangent of 2b, all divided by 1 plus the tangent of 3b times the tangent of 2b. Am I dealing with the sum or difference of sine, cosine, or tangent? Tangent. Is it a sum or is it a difference? Difference, because it matches on the top, is opposite on the bottom. That is difference. So this would be cotangent of B. Yeah. What I am going to do now is I'm going to hand out to you the start of 5.4. That concludes all of 5.3 right there. Done. What did I say? Half an hour? I was off by 5 minutes. It was 35 minutes. I apologize for my lack of skills in my estimation. Okay. Okay. Your goal before you come to class tomorrow is to do the front side of the first page and the back side of the first page. Your goal tomorrow, before you get to class tomorrow, because we're going to pick up tomorrow at the third page. Okay? So this is your homework for this evening, and it is a tonight homework.